All right, so this is part two of the gCreate rocket. In part one, we showed you how to, well, first we broke down the rocket we already created, and we showed you how to start designing some of the components within it. And we're going to go ahead and take the rest of them. We're going to finish off the rocket. We're going to copy all the parts together. We're going to Boolean it, and you can see the final model. So the rivets on here were made by essentially doing the same thing. I took a series of spheres. I laid them out to where I was happy with one. I rotated them around to make a series of what, 6, 7, 8, 9, or 8. And then they didn't. They had a little bit of a bend on there, but in the end, I went ahead and attached them all together. So now they are a solid model. So you'll see that they still have separate entities inside of the edible mesh, but they're still considered one solid piece because what I wanted to do to help with the Booleans was make all the rivets one model. So if I go ahead and isolate selection now, you can see all the rivets floating around. So that's just one way to save you from doing more Booleans because later on, as you'll see, if I have to select each one, it might be two minutes per to select each one. So you might be sitting here for an hour selecting these stupid little spheres. um, Okay, so here's the porthole. What I'm going to do is show you the back of the model actually has the same porthole, and the other side of the model has also the same porthole. So I can go ahead and actually delete these, because what you really want to do is you work on one, and then you rotate and copy it around. So to do that in this particular model, I made sure that everything is set up on this world axis. This is the 0, 0 point of the entire world, which is very useful that if you're trying to rotate things around, you can select the world as your kind of your base point and rotate around that. So I selected, let's say, this is the same way you do it for the fins and everything else. You select your particular object, whatever you want. You want to go to your rotate. Up here, you go to where it says view. I pick world. And then you have a use selection center, means it'll use the center of all the objects you have selected. Well, that's not what we want. We want to have the world center. So if you click this and hold it and go down to the bottom one, now my rotation is around the world. So I can actually rotate all around the world itself. This is very useful. Um, this is going to be kind of a 3ds Max tips and tricks tutorial, but if you hold shift while rotating things, it'll actually make a copy. And you'll see there's a number there that says 75, 80, 95, 90. That's 90 degrees. That's what we want. So copy it once and let go of everything. And now you have your clone options. What we want is copy in this particular situation. What instance will do is make an instance of the original part. And if you ever modify the original part, all the other ones will also modify and update accordingly. So you can make one little porthole, make 10,000 instances of them, and all the other 9,999 will change if you ever modify the first one. That doesn't seem to work really well with Boolean operations. So for this example, I just want to use copy. And what I want to do is 2 copies because it'll copy one here and also another 90 degrees on the other side. So let's go ahead and make 2. If you want to change the name here, you can. So now what that did was take the original, make 1 copy, and then made a second copy. So now we have this on 3 sides of our model. On the 4th side, this was created the same way as the original, only I made it bigger so that it can fit this big porthole. And this here is literally just a sphere. So it's actually just a sphere that's been turned and rotated and cut in half so that it actually fits in that porthole. So using these operations as far as rotation and arraying around, you can work on one part of the model, copy it around, and retain all these modifiers. It really makes it simple to kind of start modifying these parts. So now we've kind of gone over, kind of quickly, but how to make these portholes, and then talking about these kind of spheres as well as these ones. These are the rivets. So after creating these portholes, what we wanted to do was add our logo to the back of the image, and also our logo, the other logo, to the front of the, not the image, but the model. So what these do later is this one will be, it's a little bit offset from the surface. You can kind of see there's a little bit, it's like stuck out of the actual porthole. This will be a union, so it'll actually bump out. And then the front one will actually be a subtraction Boolean, so it'll kind of be embossed into the actual porthole. So this was actually our logo, which we added. Here's the logo itself. Let me go ahead and go to isolate. I hit P for perspective and Z to zoom into my model. So now here's our original logo. We added one bend modifier, second bend modifier, and then a bevel. What the bevel did was give us two kind of beveled edges. It just seemed to kind of work better. You can kind of see this kicks in a little bit. This worked a little bit better when we were trying to Boolean it out. A straight up extrude modifier works a little bit differently. But this is just another modifier called bevel, which you can set different bevel heights. So now we had our logo in the front, which is being prepared for later. Our logo in the back, which will be used later. We have our portholes, and we have our center body, which has the hollowed out center portion of it, as well as the nose cone at the bottom. It's all part of the same model. And if I hit F3, that'll go to wireframe mode. You can see this whole pile of lines here. This is the actual nose cone portion, which actually holds the smoke for the rocket stand. And some people had issues on the bottom. We actually created support material in the model so that when you print it, you didn't have to add support. But I guess this gap between the two had a lot of issues. So in the end, I think we just went ahead and took this out when we uploaded it, or you'll see that you have to add support below the model for it to actually work. Okay, so this is the main body. The last thing I guess I didn't show real quick was this little box here is the sliver, or the hole where you can actually add quarters. So we made sure it was just big enough to be able to slip quarters into your money bank. Now, here's the fins on the outsides of the rocket. This is the fins that hold up the rocket itself. These fins are created in a similar fashion. You'll see this is just simply a line here, which has a lathe modifier, which just lathes it around. So now it's just a circular kind of, rocket pad, or whatever you want to call it, like a leg of the rocket. This here was a series of different, different operations. Let me go ahead and go to the isolate selection. So now you can see just that model. When this started, it looked like this. It's just a box that was, we took the certain vertices and kind of pulled them around. You know what? Better yet, I'm going to show you this back in the model itself. So I think this was 6 inches off. Yeah. So here we had this plate here. This is one of the I guess you could say modifier based models. It's an actual polygonal based model, edible polys. And edible polys are fantastic, and they're really a lot of what you use in 3D Studio Max. So when we started with this, it's kind of like the edges of the fin where you just had this little like raised edge. We knew that we were going to take a base model, which started as a box, and then you'll see that there's parts where it intersects the model, and it's not really smooth, it's kind of blocky. But that's great, because this is supposed to be the base geometry for something we're working on later. So if you take this edible poly and add a turbo smooth modifier, what that does is it smooths out all the edges using this really nice algorithm, which will give you kind of curved edges, smooth out your model, but also it allows you to retain the original object. So I can always go back later, go into my, hit the plus and go to my vertex mode so I can select the vertices. I can pull this wherever I want. If I go back later, that'll update the model to fit whatever changes I made. I'm going to hit Control Z to go back. Anyway, so basically this is an edible poly which has been smoothed out with a turbo smooth modifier. There's other modifiers in polys themselves. If you go to the actual edible poly and go down to use NURM subdivision, this is another way to smooth out your model, but I think turbo smooth sometimes works a little bit better. And again, this is just a modifier. Now, the third thing you want to do, if I go to isolate selection, is still close off the back of the model. So this is not a solid model. It's just basically like the shell of something. To close off the back, I want to go to cap holes. Now this is a solid model. It filled in the back. It's capped, so then when I go ahead and use it later with a Boolean operation, it'll Boolean out a little bit better. Okay, so in a convoluted way, that's the three processes where we use to make this original kind of edge of the fin here. And then we have the fin itself was also created in a similar fashion, where we took a box, we kind of shaped it the way we wanted, we smoothed out the edges, and then made it an edible poly. And then in this particular example, you already see we've also made another union where we subtracted out a portion of the inside of the model because it was too big. But this is some of the spots where you want to do a little bit more free-form modeling. It's not all, everything is not just using basic modifiers and basic spheres and boxes. Sometimes you need to get into a little bit more free-form modeling to make these parts work. So as you saw inside here, this particular model, one thing I want to mention is that if I select both these by holding Control and then isolate selection, you can see these two models. This actually not only intersects this model, but it actually goes inside of the model. So you'll see it actually on the inside, there's a big flat spot. Now that actually doesn't matter to us. We could have carved that out so that the inside is nice and smooth, but it's a piggy bank, so who really cares if this is on the inside as long as it's a clean edge. So I see if I go to the edge here, let me go inside actually, kind of see parts of it. It's still a nice clean edge on it. It's not, the inside part of the model is actually not expanding too far. So that's okay. So what we have now is this one completed fin that has this kind of rocket cone here with a fin and then this edge here, which will intersect the main model. Because we have one of these, in this example I happen to delete the front or the back two or whatever. So what we can do now is select all three, go to rotate, and just like before we want to go to world, and we want to set this to the bottom. Now we can rotate around the world. And we can go ahead, let me turn on angle snap. Hold down shift, go ahead and set it so this is 120 degrees. You can also see it in the very bottom of the window. Let it go here, hit copy. You want to copy it twice. And there it is. That is, now you have three fins. If you ever need to modify these fins, don't modify the second or third ones. Always modify the original, because then you can always go ahead and just copy it around again. And there's other ways you can use modifiers that'll do it for you, but this just happens to be so quick. It's a very simple process. So here you see we have a lot of the components we're starting to build up for our model. We have the main rocket. We have these rivets, which are not part of the model yet. We have these portholes, which are also not part of the model. You'll see if they're actually intersecting the model quite a lot inside of here. The fins in the corner are intersecting the model. Everything is here, but it's also intersecting the model a lot. And you'll find with the next steps as we start using the Boolean operations, you're going to spend a lot of time cutting things out and trying it. It's not going to work right. You're going to have to come back again, tweak the original geometry, cut it out again. It's a bit of a process, but once you're done, you should have a very clean, simple model that you can go ahead and export as a solid manifold model. Now we're going to start using the Boolean operations. And in the case of this model, there was a lot of back and forth early on, so I'm not going to show you that now, obviously, because the model itself works well. But there's a lot of trial and error, trying to make sure it works right, going back, trying again. But in the end, the model came out manifold, and I was very happy with that. So first things first, I'm going to take these fins on the bottom and just get them out of the way by holding down Control and selecting all of them. I'm going to move them over, let's say 10 inches, just get them out of the way. Oh, by the way, if you ever need move transform, if you need to be able to pop this window up, you just hit F12, and that'll make that thing pop up. It's a very useful way to type in how far you want to move something. All right, so now we have this main model. As I mentioned in the beginning of the video, when we use the Boolean operations, it takes a long time, so a lot of this will be cut out. So it may seem like it's very quick, but in reality, it's not that quick. At least early on it will be, but as you start adding more geometry, it gets slower and slower. So the first things, this model here already has a lot of faces. If I zoom in on the bottom, you can already see how clean the model is and how nice the edges are. So take this. You want to go back to the Create tab. From where it says Standard Primitives, go down to Compound Objects, and now select Pro-Boolean. Now you have the option to start adding a series of different Booleans. And what a Boolean is, it's a way to either add geometry together, subtract geometry, basically create geometry where the parts intersect, where they don't intersect. There's a lot of things you can do with it, but in this case, we're just using union, which will basically combine two pieces of geometry together, and subtraction. Also subtract one from the other. So the first thing first is union. Scroll up and go to, scroll down and go to Start Picking, and you want to pick, first things will be the rivets. All right, just so you know, that first operation took about 20 seconds, 25 seconds. So it might seem like this goes quick, obviously because of the video, but just keep in mind that if you're doing heavy geometry, these Boolean operations can not only take a long time, they can crash your program, all that stuff. So always save your work and always be prepared that there might be issues. So anyway, so before continuing with the other Boolean, I want to go ahead and take the ones we put off to the side. They will be much quicker. So instead of showing you the whole entire other side first, let's do these. So leave the other ones alone. Come over here. You're going to go ahead and select, these are the fins we saw earlier. So go ahead and select just one of them. You're going to go to the Create tab and then go down to Compound Objects. Click pro-boolean. And now you can do your union like we want. So all of these are going to be union together. So go ahead and click that, click Start Picking, and just start picking them. And you'll see this is in real time. I'm not speeding up the video. It's much, much faster to do these because the geometry is so much simpler. But you will see as we select more, it's getting a little slower and a little slower each time. So you'll see on the main rocket, that's why it takes so long to Boolean things, because this is clean, simple, and they're not really that dense. But as you go to the other models, it can be much slower. So let's go ahead and continue that now. All right, so the total time for the entire Boolean was about 15, 20 minutes. So I took the fins that you saw earlier, and I brought them over and I unioned them to the original model. I subtracted out the logos and I've unioned all the spheres and the rivets and everything. So in the back you'll see this logo. Actually, instead of unioning it, we decided to subtract it. I think in the final model it might be a union because it's sliced funny. But anyway, so this is the final model. It came out great, but again, it takes a long time sometimes. And we've gone through hours of iterations with this because if you union something and it screws up or it doesn't reunion right, you might have to undo and do another 5-minute operation. So just keep that in mind. But here's the main model. It looks really good. We're happy with it. It has those flat spots we talked about earlier. These bottom cones or whatever are actually a little bit thicker because people had issues printing this area here is a little bit too small. And then the nose cone itself, as I mentioned earlier, has the kind of snake-like pattern here. This as well is also a Boolean. It's actually just if I take these three, should be pretty quick. I'm going to extract out the original operations. I'm going to delete the new model. Now you can see if I hit F4, that brings up facets. You'll see that the original model is simply just a lathe. Just took a spline which goes all the way up and I lathed it. The cool thing about that, again, as I mentioned earlier, is I can go to the original vertices and pull something out like that. When I go back to the lathe, it'll now be in the model. So these parametric software options are really nice. The lower portion is actually, this was created from a series of, if I isolate this, this was like a box that had a bend on it. This is another, actually no, I'm sorry. This is a cylinder with a very specific depth. This was a cylinder, that was a cylinder, this had a skew modifier on it. Very simple things to make this pattern. And then I added a shell modifier in the end after deleting the other faces. So what it took was this, or it took this kind of like polygonal model and gave it depth and thickness. So I think it's 3/64 of an inch. Yeah, I know it's not metric, but yeah. So and then we went ahead and took that. If you go to the Boolean operations, as we mentioned earlier, under pro-boolean, we want to subtract out this one. It should be pretty quick. Yep, because it's not that dense of a model. But now you'll see this is the negative kind of space for that little puzzle there to operate. And then the other side, we mirrored the same pattern. Or I'm sorry, rotated the same pattern. And then also I can go ahead and go to subtraction. I can add more than one thing, so I can just pick another one, subtract it out, and there you go. So the cool thing with this top little locking mechanism is you can make 10, 20 different designs of different shapes or whatever, so that no one knows how to get in your little money case here. And here's the little the little spheres that actually lock into the actual the keying mechanism. So. Alright, so now we've shown you how we made the original rocket and some of the cool techniques we used in 3D Studio Max. So when we made the original rocket, we actually wanted a stand for it. So to make the stand, we actually made a cool particle simulation smoke kind of thing in 3D Studio Max. So go ahead and stay tuned to part 3 if you want to see that and see the simulation and editing tools we used. And keep continuing to watch our gMax 1.5 plus 3D printing rocket tutorial. Check it out.